Welcome back to our statics video in which we are working on example 5.3 from the textbook. We're doing a frame analysis. This frame, if you'll recall, I'll make a little sketch of it here, basically consisted of a post with a horizontal boom that was supported by a diagonal brace. And so we need to find the pin reaction forces at these three joints that connect the boom, the brace, and the post. We started with the boom and found the reactions there. We then went to the brace, found some more reactions, and now the only thing left to do is check out the post. So we have here a free body diagram of the post. When we first started our analysis, we found the reaction forces. We found that we had a 13,800 pound vertical reaction at A and 11,070 pound horizontal reaction. Up here at B, at the top of the post, we have an 11,070 pound reaction force to the left. So this force and this force, those reaction forces cancel each other out. Through our analysis of the boom and the brace, we found that we had a horizontal reaction at E. It was pushing the brace. If I sketch out this frame again, but in pieces. So the pin reaction here was pushing up against the brace and down against, up against the boom, down against the brace. It was also pushing the boom to the right. It was pushing the brace to the left. And the horizontal joint here was pushing the brace to the right, it's pushing the boom to the left. So the way that the pin affects the frame member, which is the way we need to think about it. It's not how the frame affects the pin, but how the pin affects the frame. The pin at E is pushing the post to the left with a force of 15,500. Also up here, it is pulling the boom to the left, which means it's also pulling the post to the right. So at joint C, the way the joint affects the post is that it pulls it to the right with 15,500 pounds. So if we sum our forces in the x direction, we should find that we have, starting from the top, working our way down, we have negative 11,070, positive 15,050, negative 15,050, and positive 11,070. Add that all up and we get 0, which is exactly as it should be. Okay, so these four horizontal forces all cancel each other out. That is confirmation that our analysis of the boom and the brace were accurate. Now if we look in the vertical direction, if we sum the forces in the y direction, we were given in the problem statement that the post weighs 1,400 pounds. So that's 1,400 pounds in the downward or negative direction. We also found that joint E, we found that it was pushing the brace up, which means it's going to have the opposite reaction on the post. It's going to be pushing the post down with a force of 15,950. From our earlier analysis of the brace, we found that it was pushing the brace down, so that means it's going to have the opposite effect on the post. It's going to be pushing the post up with a force of 3,550. And let's see, is that it? We've got 1, 2, 3. Oh, and the reaction force here at the bottom. That's something we found when we started our analysis. That is up in the positive direction, 13,800 pounds. So if we add these all up, we get 0. So again, this is just confirmation that everything we did up until this point was correct. All of these vertical forces applied to the post cancel each other out, and that's as it should be. And if we wanted further confirmation, we could sum the moments about any point. For instance, we could sum the moments about A, which would be counterclockwise or positive rotation of 15,500 times 2 minus the opposite rotation, 15,500 times 12, and then positive 11,070 times 14. Now, when I sum those forces together, I'm actually not getting exactly 0. I'm getting negative 20. But I would say that is close enough to being 0. That is small enough, considering the magnitude of the forces we're talking about that are in the tens of thousands of pounds, that we would have a rounding error of only 20 pound-feet is pretty reasonable. And it is just rounding error. These answers, this 11,070, for instance, I know was just rounded off to 4 significant figures. There was something else there when I calculated that, and we just rounded that off. So since all of these answers probably had some degree of rounding, you can see that rounding error evident in that result there. But it is very close. It is very close to being 0. So again, that's just further reassurance that we have done everything correctly. So here is the final result here, summary of all the reaction forces in the diagram. And again, you can see how, let's look at joint D, for instance. It pushes up against the boom with a force of 15,050, which means that it must be pushing down against the brace with an equal force. So the sense or direction of these forces, the way they, the reaction that the pin has on the frame member is opposite, meaning that if we look at joint C, for instance, the pin was pulling the horizontal boom to the left, which means it's pulling the post to the right. So every pin connects two framing members together, and the reactions it has on those framing members are in opposite directions. Another way that we could summarize our results here is in a table, and I'm going to recommend that you do that for your homework assignments. So the way we could do that is, say we've got our joint A, which is our support. We have our joint B as well, which is another support. And then we have C, D, and E. Those were our internal pins that we found the reaction forces for. We can make a table for the X and Y reactions. So A in the X direction, 11,070, and in the Y direction, 13,800. For B in the X direction, 11,070, in the Y direction, 0. C in the X direction was 15,500, and in the Y direction, 3,550. At D in the X direction, 15,500, in the y direction 15,050 and E in the x direction 15,500, and in the y direction it was 15,950. And just leave all of these values as positive because the sign doesn't really make a whole lot of sense. For instance, if we look at joint C in the x direction, well, if we look at the force that joint C exerts in the x direction, it's going to the left when we're talking about the brace, but it's going to the right when we talk about the post. So which is it? Is it to the right or to the left? Is it positive or negative? So that's why putting a plus or minus sign on any of these values in a table doesn't really make any sense. We can describe the magnitude, but we can't really say for sure if it is right or left, because it depends on the situation. It depends on which frame member we're referring to. So I would like to see you use a table like this to summarize your results. It's also a good way to check yourself to make sure you actually answered all parts of the question. If you've got any missing blank spots in your table, then you might need to do some more analysis. So that's our first frame analysis example finished, and in the next video we'll look at one more.